Hello everyone. The title of this video is the slope of a line. Now every example I'm going to be doing in this video is taken directly from a free online textbook at openstax.org. I'm in their Algebra and Trigonometry text, section 2.2 on linear equations in one variable, even though we're starting to get into linear equations in two variables as well, basically just linear equations. And I'll be working under the objective with heading the slope of a line in the text. Now each example I take that I'm going to be doing in this video is either from the examples in the reading here or from the try it problems you'll see in the reading, or from some of the exercises at the end of the section that are also related to this objective. I will have timestamps as well for when each example begins in the description of the video below. And I also request that whenever I start a new question that you pause the video and try to work it out yourself first before watching me doing it and comparing. Because if you're watching me do these things and not practicing yourself, well, chances are you're not going to learn all that much. Alright, so all the examples I'm going to be doing I have written out on paper. Let's take a look. And we're asked to find the slope of a line, right? Find the slope of the line that passes through the given points. Right? So we're into the XY coordinate plane, right? The Cartesian coordinate system again here. And before I get into this example, off to the side of the page, I want to talk about the slope of a line. Right? The slope of a line, it's a number. It's just a number. And it's a number that, is the ratio. It's a ratio, a fraction usually. Is the ratio of the vertical change to horizontal change between any 2 points on a line. This is between any 2 points on a line, a straight line. And another thing this number tells us, this slope number, it tells us, what direction a line will be going in on the Cartesian coordinate plane, the XY plane. It also gives us an indication as to how steep the line is, right? How fast it's rising or falling. So here's how we calculate slope of a line, right? I told you right there how to calculate it. That's the ratio of the vertical change, right? This is in the y direction, going up and down, to the horizontal change between any 2 points on the line. All right, so what I have drawn here is a rough XY coordinate plane. Right? You got your x-axis, the horizontal axis, y-axis is vertical, and then if I draw just some line, right? So here's a line right there, nice straight line of points on this coordinate plane. And say I was asked to find the slope of this line. In order to find the slope, right, the slope of a line, you need 2 points, any 2 points on that line. So let's say this point here, it doesn't matter, this point here and this point over here. and these points have coordinates. So this first point, let's say this first point has coordinates x1, right, for the x coordinate of the first point I chose, and say it has a y coordinate of y1, right, for the y coordinate of the first point I chose. All right. And then this second point I chose, it has an x coordinate. Let's say that has an x coordinate of x2. It also has a y coordinate. Say the y coordinate of that second point is y2. Right? Okay. Now imagine traveling from one point to the other. Right? Imagine traveling from one point to the other, but you can't go just directly on the line. You have to go on the grid. Right? You have to go, if this was graph paper, you'd see a grid. You have to go left and right and up and down. Right. So imagine I'm starting here at this first point with x1, y1 as coordinates, and I want to end at this point over here on the line. Well, how I would have to travel would be this. I'd have to go to the right. I'll put little arrows here. We'd have to go to the right from x1 to x2, and then we'd have to go up. Again, little arrows say going up. Right. So in my picture here, there's an increase in x, right? You go from x1 to x2. If you go to the right, you're increasing the x coordinate, right? If you go to the left, you're decreasing the x coordinate. And I went up, so there was an increase in x. There was also an increase in y, right? If you go up from, say, this y1 to that y2, if you go up on the y-axis, you're increasing the y coordinates. If you go down, that's a decrease. Right? And for slope calculations, increasing is a positive change. Right? You'll end up with a positive value for how much you have changed. Right? An increase is a positive change. If an x coordinate or y coordinate decreases, if you go to the left on the x-axis, or if you go down on the y-axis, if there's a decrease, that will be a negative change. So please, keep this in mind. This will be huge. Right? Now these changes, how do we calculate them? Well, always take end minus start. Take end minus start values to calculate anything. So if I started at this point with coordinates x1, y1, and ended at this point with coordinates x2, y2, the change in y, which you may have seen this before, delta y, it's this here, delta y, means change in y. And the same thing goes for delta x. It's a little triangle symbol. It's the Greek letter delta. It's usually used to represent the words change in. And then this length here is the change in x, right, delta x. So I take the end y value for the change in y, the vertical change. I take the end y value minus the start y. So in this case, it would be y2 minus y1. And the change in x would be, again, n minus start, x2 minus x1. Right? And the slope right? The slope of this line, which is usually, instead of writing out the word slope all the time, is usually represented by a lowercase m. And it's from the French monter, to go up, to rise. I believe that's where it came from. Anyway, the slope is usually represented by a lowercase m, and again, it's the, as I described it up here, the ratio of the vertical change to the horizontal change, a fraction. So the change in y, delta y, divided by the change in x. All right, vertical change over horizontal change, where it's y2 minus y1 for the vertical change, and then x2 minus x1 for the horizontal change. And like I was saying here, these have to be taken. I know this is really cluttered, I apologize. These differences, these changes, have to be taken in the same order. So if I did y2 minus y1 in the numerator, I can't do x1 minus x2. You can't just switch the order. It's got to be the second x minus the first x in the denominator. And they might also call this rise over run. You might see that as well. Rise, the vertical change, how much up and down are you moving from one point to the next, divided by the run, the horizontal change, how much are you going left and right to get from one point to the next. All right, so that is very cluttered. But this is it right down here, slope, the slope calculation. Okay. So, very, very cluttered. But let's see what happens. All right, let's do this with an actual set of points. So I got the point negative 2, 6, and the point 1, 4. All right, so I'm going to label these with the negative 2, 6. Let's call that x1, y1. Right, negative 2 is x1, 6 is y1. And then x2, y2, the second x and second y for 1 and 4. And I'll draw a very rough sketch of the xy plane again. And I'll plot these points, and I'll draw the line that passes through them. So negative 2 on the x, 6 on the y. So that's this point here. Negative 2, 6. And then 1, 4. So x is 1, y is 4. That's this point here. And so you see we have a line that's going down to the right. The line passing through these 2 points is a line going, this way. That's kind of a crappy line. I am so sorry. Should have had a ruler or something. All right, but there's the line, containing these points. Negative 2, 6, and 1, 4. All right, now to calculate the slope of this line, right, the slope again is usually represented by lowercase m, and like I said, it's change in y, vertical change. All right, if I were to go from here, let's say I was go from that point to that point, negative 2, 6 to 1, 4. See, the vertical change is this right here. Right, there's the vertical change, the delta y. And you see how I'm going down? That's a decrease. All right, that's a decrease in y. So delta y is going to be a negative number. All right, remember I told you, if I'm starting here, ending there, you always do n minus start. So 4 minus 6. All right, I'm doing 4 minus 6 in the numerator of the slope, the change in y. which you see as a negative. That means down 2. Down 2 units, right? That's negative 2. That means I went down 2 units. I decreased the y by 2 units. All right, and then the change in x, right? The horizontal change in the denominator. Again, starting at negative 2, 6 and ending at 1, 4, I go down and then I go to the right 3 units, right? So we're seeing that delta x here, again, n minus beginning is 1 minus negative 2. That's a positive 3, right? That's right 3. That's a increase of 3, a positive change. And it's 1 minus negative 2, but it's got to be, second y minus first y in the numerator, and you got to do it in the exact same order in the denominator. Second x minus first x, 1 minus negative 2. And so the numerator is negative 2, the denominator is positive 3, and there's the slope. They say the slope is negative 2/3. Right? And that's what we're asked to find here, right? What's the slope of this line? Passing through those 2 points, it's negative 2/3. Now, what does this mean? Now, that you can actually use the slope to find any points on the line now. You can find because this slope should be the same. It should be the same ratio for any 2 points on the line. So you know what? Let me draw this a little bigger, and then I'll go to the Desmos.com website. That free online graphing calculator, and we'll take a better look at this. But let me make this a bit bigger over here. Maybe this will be better looking. So here's the x-axis, the y-axis, and we had what, negative 2, 6. So make my picture on the left side bigger. So there's negative 2, 6, and then 1, 4. Right. Trying my best to keep things as evenly spaced as possible. And then the line, right? The rest of the line, I'll draw it this time in red here. Let's just go. Here's the line that passes through these points. If you have a ruler and graph paper, that would be great. And let me actually label these two. So there's negative 2, 6, and then 1, 4. Okay, great. And like I said, you can think of this as, this rise over run. From this point, I go down 2, right 3, right? Down 2, right 3. And then you could do it again to get to another point on the line, right? If I go from 1, 4, if I go down 2 units, negative 2 change, and then right 3, we should be on the line again. There, right? And if I go down, if I decrease y by 2 from 4 to, that makes the y coordinate 2, and then I increase the x coordinate by 3, that goes from 1 to 4, right? So the point 4, 2 would also be on this line. All right, and then I could keep doing this. Right? I could keep doing this. Go down 2, right 3, and we're at another point on the line. And that would actually be 7, 0. That would be the x-intercept of this particular line. Right? And not only can I keep going down, but I can keep going up. Just follow the same pattern all the time. So instead of going down to right 3, I go left 3. So if I'm at negative 2, 6, I can go left 3 units. to negative 5 for x, and then up 2. We get negative 5, 8. Right, negative 5, 8 should be on this line. Sorry if it doesn't look like it is, but there's negative 5, 8, right? And that was just doing the same pattern, right? This 2 down, 3 right, or 3 left, up 2, same thing. Right. But not only that, right? So far all my points here have, integer entries, integer coordinates. But as long as the change in y over change in x comes out to be negative 2/3. So I could go, let's say I'm at 1, 4. I can just go to the right 1. If the horizontal change is 1, then the vertical change would have to be negative 2/3. So I go down 2/3, right 1. Right, so there's negative 2/3, right 1. Down 2/3, right 1. Here's another point. And that would be 2, and then 3 1/3, or 10/3. 2 and 10/3, 2 comma 10/3. That point should also be on the line. And I can keep doing this, go to the right 1, and then I'd have to go down 2/3. If I go down 2/3 and then right 1 again, right, so here's down 2/3, right 1, I'm at another point, and this would be 3 8/3, right? 3 8/3, and then down 2/3, right 1, you get 4 2, 4 6/3, right? So you could keep doing that. Again, as long as the ratio of vertical change to horizontal change is negative 2/3, it doesn't matter. So like, how about up here? I could go down 0.2, negative 0.2, and then go to the right 0.3. 0.3, down 0.2, right 0.3. I'd be at this point, which if I go down 0.2, that goes from y equals 6 to y equals 5.8. And if I go right 0.3, I'm at negative 1.7. So, sorry, that's negative 1.7, comma 5.8. That would also be on this line. Right? Just know that the ratio of vertical change to horizontal change between any 2 points, as long as it's negative 2/3, as long as that ends up being negative 2/3, vertical change over horizontal change, you are still a point on this line. Now let me show you a much better picture of this, right, on a free online graphing calculator. It's at a website called desmos.com. I'm pretty sure I've shown you this in previous videos. Alright, so let's start plotting all these points. We had negative 2 6, there it is in green. 1 4, right? There it is in purple, and I'll change the colors at the end. But then remember, I can keep going, right? If I go down to right 3, as long as the vertical change over horizontal change is negative 2/3, right? Then we had 4 2, right? And 7 0, right? You see these 4 points that showed up, they're definitely looking like they're falling on a nice straight line. All right, I'm going to keep going. Going backwards, from negative 2 6, I went left 3 up 2. That was negative 5 8. All right, but then remember, I went from 1 4. I went down 2/3, right 1. Right, down 2/3, right 1. That gave me 2 comma 10/3. Right, and then do it again. You have 3 comma 8/3. Right, and you see how all these points are showing up in a straight line. Then I did what? I went from this 2 negative 6. I went down 0.2, and then to the right 0.3. So that would be this point. That was negative 1.7 comma 5.8. And look at that. I mean, it showed up right here. And these are all falling on a nice straight line. And this is a line going down to the right. And you could do this all day long. Right? You can find more and more points using the slope all day long. All right, but obviously I'm not going to do that. Let's just clear all these away. And get back to the paper. Wonderful, but the slope was negative 2/3. And notice a negative slope line is going down as you go to the right. Is going down like that. We'll write out more in general the direction the line will go in given the slope later. All right, so let's do that again. All right, example 2, given another 2 points here, 5, 4, and 7, 9. So again, you can label these x1, y1, and x2, y2, and then the slope of the line with these points on it, right, lowercase m again, is, the change in y, that's the rise first, vertical change. So I'm going to do 9 minus 4. Right, I subtract the y coordinates, and then make sure when you subtract the x coordinates, you do it in the exact same order. Right, I took the second y minus the first y for the change in y. I have to then take the second x minus the first x, 7 minus 5, for the change in x, and then we simplify this fraction. 9 minus 4 is 5. 7 minus 5 is 2. Right? So this is 5 halves. The slope is positive 5 halves, and that's all they're asking us for. Right? Now let's see what other points we can find. All right, let's see what other points we can find. So I'm going to go to the XY plane over here. Again, I'm going to make a rough hand drawing. If you have some graph paper, that might be a little better. All right, so here's the XY plane. Got 5, 4. Five, 4. There's that point. And 7, 9. And here's this point. And the line going through them, and the line containing these is this line here. And you see how this line is going up to the right, and there was a positive slope, right? The last line had a negative slope, and it was going down as you moved right. And you'll see that I'll write that out eventually. That's going to happen in general. A positive sloped line will be moving up to the right. A negative sloped line will be moving down to the right. And we'll talk about 2 other kinds of slope coming up here as well. All right, and let's see what other points we can find. Right. So again, from here to here, I went up 5. Right, that's 5, positive 5, an increase in y, and then right 2, positive 2. And you can keep doing that. Go up 5, right 2, up 5, right 2, and you'll have another point on the line. Extend this. We'd get another point on the line, right? If that was again up 5, right 2, this other point, if I increase the y coordinate, this is the point 7, 9 here. If I increase the y coordinate by 5, that'll have a y coordinate of 14. And then I'm increasing the x coordinate by 2, so that'll be 9. The point 9, 14 would also be on this line. But you can go the other way as well. Right? Instead of going up 5, right 2, up 5, right 2, you can go left 2, down 5, left 2, and then down 5. Here's negative 1 on the y-axis. And we're at this point, which would be 3, negative 1. Right? This point here was 5, 4. And again, I'm going left 2, down 5. Right? So if I subtract 2 from the x coordinate, that's 3, and then subtract 5 from the y coordinate, that's negative 1. 3, negative 1 would also be on this line. And like I said in example 1, you don't have to, it doesn't have to be whole numbers. You can go fractions. As long as the vertical change divided by the horizontal change is 5/2. Right? So I can go from this point. I can go up 2.5. I can go up 2.5 and then write 1. And if I do that, go up 2.5, that'll have a y, from 5/4, that'll have a y coordinate of 6.5. 5/2 is 2.5, right? 2.5 over 1, vertical change over horizontal change will be 2.5, 5/2. And then go right 1, that'll be 6. So 6 comma 6.5. That's another point on this line. Something else I can do. How about I go up 0.05 and then down right 0.02. So here, say -3, -1. Say I go up 0.05 and then right 0.02, very, very tiny change. If I do that, if I go up 0.05, that'll be -0.95 for the y coordinate, and then go right 0.02, that'll be 3.02. 3.02 -0.95 should be on this line too. And again, I'm going to make a little drawing. I'll make this on the Desmos site just to show you. All right, so we got these points. We got 5,4. There's that point showing up. We got 7,9. There's that point. I plotted 9,14, which you can't see because let me just zoom out a bit. Right, there's 9,14 up there. Then use 3, -1, right? 3, -1. And again, hopefully you're noticing that all these points look like they're falling on the same line that's rising to the right. 3, -1. Then I used some fraction stuff, decimals. We had 6.5, right? And look at that. I mean, I'll zoom in, but here was 5,4. I went up 2.5, right 1, and then from here you go up 2.5, right 1. You're at this point. And you can keep going up 2.5, right 1. And the ratio of vertical change to horizontal change will be 2.5, will be 5/2, the slope of the line. And then the last one, which I'll definitely zoom in here. I went from this point, I went up 0.05, 5/100ths, and then right 2/100ths. Right, let's see what happens. So I went, that was the point 3.02. And then -0.95. And look at that. I mean, those are definitely on this same line with those other points. I mean, I know it's hard to tell, but, these are on that same straight line. Let me just do that one more time. Let's go from this point. Again, I'll go up 0.05. Oh, I put 3.02. That's why I looked a little off. Oh, that's right. I went up 0.05 and then right 0.02. Right. So if I do that again, go right 0.02, that'd be 3.04 for the x coordinate. And then I go, right, that's right 0.02, and then up 0.05, that'd be -0.9. 0.9. Right. You see that again? They're falling on the same line, and these should be on the same line as the points I had up there. I know it doesn't look like it, but those are on the same line. This is really close. Okay, but it doesn't matter what 2 points you're looking at, as long as the ratio of the vertical change divided by the horizontal change, right? The ratio of the vertical change to horizontal change is always, the slope is always equal to, in this case, it was 5/2. Great. I'm hoping this is making sense, right? I got a lot of clutter here, but number 3, same deal. So again, I'm going to call -5,4 x1 y1, and then call 2,4 x2 y2. And again, we can very easily calculate the slope of the line passing through these points. So change in the y coordinates, I'll do second minus first, 4 minus 4 in the numerator. And then the change in the x coordinates, again, second minus first, 2 minus -5, which will be 2 plus 5. So I have 0 in the numerator, 7 in the denominator, but 0 divided by some non-zero number is 0. So the slope of this line is 0. All right, now let's see what this line looks like. A positive slope, the line was going up to the right. A negative slope, the line was going down to the right. What happens when the slope is 0? So again, making another xy plane here. Plot these points, -5. There's -5 on the x and then 4 on the y. So here's that point. And then 2, 4, right? 2 on the x and still 4 on the y. Right? So they're on the same level on the y-axis, right? The line going through these is a horizontal line. Right, this is a horizontal line here. And that's going to happen if you ever have multiple points with the same y-coordinate on the same line. So a horizontal line has a slope of 0. Right, so easy. You just don't move up or down, and then you keep moving right or left, and you'll find other points on the line. So here's -4, 4. Here's -15.2, comma 4. Over here's pi 4, right? Every single y coordinate is 4. It doesn't matter what the x coordinate is. Right? Very easy. So I'm not even going to show you this one on the Desmos site. It's just all these points are on a horizontal line. All these points have some x coordinate and 4 for the y coordinate all the time. Slope is 0, horizontal line. Wonderful. Okay. All right, and then my last example, and then I'll get into what happens in general. All right, I'll write out a page for that. So here we have, in example 3, the points had the same y coordinate. Well, here in example 4, these points have the same x coordinate. So again, I'm going to call this, x1, y1 for the point 3, 2, and x2, y2 for the point 3, -2. And let's calculate the slope. M equals, right? Now remember that I like doing second minus first, so -2 minus 2 for the change in the y coordinates, the vertical change, the change in y. And then again, second minus first for the horizontal change, right? 3 minus 3, subtract the x coordinates in the denominator. So the numerator is -4, and the denominator is, 0. Remember, you can't divide by 0. So what does that mean? That means that the slope is undefined here. They would say that this line has an undefined slope because of this division by 0. Remember, dividing by 0 is an undefined operation. Now let's see what kind of a line we get when I draw these points and draw the line that goes through them when the slope is undefined. So here again, the xy plane. And we have the points 3, 2. There's 3 on the x, 2 on the y. Alright, so here's 3, 2. And then 3, -2. Right, so 3 on the x and then -2 on the y. It's this point here. And you see how they're directly above and below each other? Right, straight up and down. Straight up and down. So what I have here is a vertical line, right? Something parallel to the y-axis. Okay. So any line with a slope that's undefined is a vertical line, or they could say a vertical line has an undefined slope because the change in x will be 0 no matter what 2 points you pick, right? Because every single one of these points has an x value of 3, right? There's 3, 0, that's on the line. Here is like, say, 3 pi, that's on the line. Here is 3 comma square root of 2, that's on the line. Here's 3 comma -8, that's on the line, whatever. Right? But every single point has an x coordinate of 3 and then some y coordinate, right? Because you don't move right or left at all. There's no horizontal change, and the vertical change can be anything you want, right? But you're dividing by 0, slope's undefined, x coordinate's always the same, a vertical line, right? All right, so we've seen a case of each kind of slope you'll come across: a negative slope, a positive slope, a slope of 0, and then a slope that is undefined. And I'll just write out what, in general, what those kinds of lines will look like on the next page. All right, so slopes. So one, if the slope is positive, right? If the slope of a line is positive, then, and I'll just draw a generic graph. Here's a rough XY plane. The graph of the line will be going up to the right, going up to the right. 2, if the slope is less than 0, right? So again, this was positive slope. The line will be going up to the right as you go to the right. Here's a negative slope, right? And again, a very quick XY plane here. The graph of the line will be going down as you go to the right, down to the right. Third case, if the slope equals 0, right, so a 0 slope, then every single point will have the same y coordinate, right? There won't be any change in y. And if that's the case, you have a horizontal line. Right? Horizontal line with a slope of 0. And then the last case, if the slope is undefined, that means you're dividing by 0 in the slope formula. There's no change in x every point. Right? That means every point on the line has the same x coordinate, right? There is no change in x whatsoever. Then you have, like in our last example, a vertical line in that case, right? All right. So I hope you keep this in mind. That way, when you go to graph things and you're asked to find the slope, if you graph a line that looks like this and you calculate the slope and it's negative, then you know you did something wrong. Or if you graph a line that looks like this and you calculate the slope and it ends up being positive, well, then you know you did something wrong. It should have a negative slope, and so on. Right? You can use this guy as a guide to help test yourself. Great. All right. So rise over run. Change in the y coordinates divided by the change in the x coordinates. Vertical change divided by horizontal change. However you want to say that, that's how you calculate the slope of a line. You need any 2 points on that line to be able to do it. All right, and I'm hoping that watching me go through these 4 examples here and writing out this little chart help you in some way, when you're asked to find the slope of a line on your own. And thank you very much for watching.